Before we look at dividing polynomials with long division, let's remember how to divide numbers with long division, because we're doing basically the same steps when we divide polynomials. This is our example, 1,538 divided by 7. So let's set up the division problem and then think about how much of this problem we have to look at for our first step. Our first step is to make an estimate. So we're going to look at the 15 and the 7. And usually we ask ourselves, how many times does 7 go into 15? Well, it's about twice. And then our second step is to multiply. 2 times 7 is 14. Our third step is to subtract. 15 minus 14 is 1. And then our fourth step is to bring down the next digit, which is the 3. Now we repeat those same 4 steps. First we estimate about how many 7s go into 13. Well, just 1. Then multiply. 1 times 7 is 7. Then subtract. 13 minus 7 is 6. And then bring down the next digit. And now back up to estimate. How many times does 7 go into 68? It's about 9. Then multiply. 9 times 7 is 63. Then subtract. 63 from 68 is 5. That last digit, the 5, is our remainder, and we're going to use that to write our answer. First of all, the 219 is the whole number part of our answer. But then we also have a fractional part that's made up of the remainder divided by the divisor, which is 5/7. So our quotient is 219 and 5/7. Now let's look at an example of using long division with polynomials. So we'll take 2x to the third minus 3x squared plus 3 and divide it by x plus 2. We already said that the process is basically the same as it is with division with numbers, although we're going to reword part of it just to make it a little bit easier to understand what's going on with polynomials. So first, let's set up our problem. We have to take the 2x to the third minus 3x squared plus 3 and divide it by the x plus 2. But I want you to notice something. The 2x to the third minus 3x squared now has another term added to it, which is the 0x. The reason for that is that we need to have every possible degree of our polynomial represented, starting with the highest degree term all the way down to our constant term. So we have an x to the third term in the 2x to the third. We have an x squared term, that's the minus 3x squared, but we're missing an x term in our dividend. So we're going to add in a 0x to our dividend, which does not change the dividend at all. We're basically adding a 0 to it. But we need that as a placeholder term as we do our division. So let's get started. The first step is to estimate. Now, how much of these polynomials do we have to look at to make that estimate? Well, as it turns out, you only need to look at the first terms of the dividend and the divisor. Now, here's where we're going to do a little bit of rewording for the estimate. Instead of saying, how many times does x go into 2x to the third, we're going to reword that and say x times what would give us 2x to the third. That's an easier question to answer. It's 2x squared. The next step is to multiply. So we're going to multiply 2x squared times x plus 2. That's 2x to the third plus 4x squared. Notice how we're lining up those like terms. Now here's where we're going to do a little more rewording to make sure that we do this step correctly. We're going to do something that's exactly the same as subtracting, which is changing the signs and add. In other words, we're adding the opposite, which is the same thing as subtracting. So that 2x to the third plus 4x squared, we're going to make it its opposite, which is negative 2x to the third minus 4x squared. And now we'll add. Negative 2x to the third plus 2x to the third is 0. And negative 3x squared minus 4x squared is negative 7x squared. 0 minus 7x squared is just negative 7x squared, so we really don't need to write that 0 down. But we do want to go to the next step, which is bring down, in this case, the next term, which is the 0x term. Now we start the 4 steps all over again. The first step is estimate, so we'll look at the first terms in the x plus 2 and the negative 7x squared plus 0x. That is the x and the negative 7x squared, and we'll ask ourselves, x times what is negative 7x squared? Well, x times negative 7x is negative 7x squared, so that becomes part of our quotient. Next step is multiply, so negative 7x times x plus 2 is negative 7x squared minus 14x. The next step is change the signs and add. So negative 7x squared minus 14x becomes positive 7x squared plus 14x, and when we add, we get 14x. Now maybe you can see why we needed that 0x term. We needed something to add that 14x to. And now the fourth step, bring down the last term. Now one more time, go to the top of our list, estimate. We'll look at the x in the x plus 2 and the 14x in the 14x plus 3 and ask ourselves, x times what is 14x? That's 14. Now multiply. 14 times x plus 2 is 14x plus 28. Then change the signs and add. 14x plus negative 14x is 0, and 3 minus 28 is negative 25. The negative 25 is our remainder, and it will become part of our answer. But first let's go up to the top of our problem and write down what's kind of the whole number part. The 2x squared minus 7x plus 14. Now that's only part of our quotient. The other part is the fractional part that we get from our remainder and our divisor. So our remainder was negative 25. Our divisor was x plus 2. So the fractional part of our quotient is negative 25 over x plus 2. Notice there's a plus sign between the 14 and the fraction. We need that there because without it, we'd be multiplying the 14 and the fraction, and that's not what we mean. We mean that we've got the polynomial plus this fractional part. By the way, that fraction on the end, we could have also written that as this, 2x squared minus 7x plus 14 minus 25 over x plus 2.